Three. Good day, everyone. My name is Nabeel Ahmed, and I have more than 25 years of experience in IT training, consultation, and also entrepreneur. Um, our topic for today is data visibility methods. I'm expecting my audience would have a background of networking and security, if not to the advanced level, but at least to the basic, to the intermediate. Also, we're gonna focus on the methods of visibility, meaning we're gonna see what are the different methods of extracting or copying the data from the network to those tools which are gonna analyze this data. So I have prepared a presentation for this purpose, and I'm gonna share it with you right now. So there are different methods to access the data from the network and different purpose. So we're not going to discuss the purpose. We're going to discuss the methods, how to do that. My next slide is about the purpose. Why do you copy the data, or why do you access the data from the network? For visibility. For visibility, for what purpose? You can see there are a list of tools mentioned here in this slide, which shows you the purpose. Maybe you want to do network performance monitoring, maybe data loss prevention, maybe intrusion detection and prevention. We call it IDS or IPS. In short, we can call it a sandbox in security terminology. So there are a list of tools which can be used to collect the data. So collecting the data is the challenge. That is our topic, how to collect the data. And that's where we're going to discuss the traditional method. The traditional access method, we call it span ports. Well, span stands for switched port analyzer. It's very common terminology. And in other words, we can call it mirroring. Now, this is very common method. This method comes with some challenges. On the left side of the screen, you can see there is a switch. It could be any vendor, Cisco or whatever. The whole idea is that we want to copy the traffic from these two clients and send the copy of the data to the sniffer. No, sniffer in this case could be Wireshark, or it could be those tools that we saw on the last slide. But the challenge is, in this traditional method, is the switch becomes very busy. The CPU and memory load is very high, because if switch is already busy doing a lot of things, switching and layer 3 switching, and if you're putting the mirroring load on that, it increases the CPU utilization. Second challenge is it doesn't forward layer 1 and layer 2 errors. Well, some of the tools in the network might want to know if they have any L1, L2 errors. So using this traditional method, you won't be able to see that. And another challenge, it needs to be configured through CLI or GUI. So there is some additional configuration. And then number 4 is mixing source and destination information. Well, this means same packet can be duplicated, but with different source and destination. And then last but not the least, the span ports have limitation. And when I say limitation, the limitation depends on the vendors. Our presentation is not any vendor specific, it's very generic. So some vendors have a limitation, like maybe 24 ports can be mirrored, or maybe a certain number of meters can be mirrored. So there are limitations. So that means we can't have a proper visibility of our data networks if we just use the traditional method. So that's why I'm going to discuss a new or better method, which is called taps. Well, this is not a water tap. This is test access port. What is tap? Tap can be a device. Tap can be a function which can be incorporated to a switch. So some of the switches nowadays, some of them depend on the vendor, they have a built-in tapping function. but most of them, they do not have it. But what the tap is doing, let's consider this as a device for now. What the tap is doing is just copying the signals, which are incoming and outgoing signals, and copying them to the sniffer or those tools that we saw in the first slide. And there are two architectures of taps. Before I proceed with that architecture of taps, if you have any questions, please raise your hands. I'm happy to discuss in detail. No questions? Okay. Well, remember, there will be a quiz in the next lecture. Okay. The two architectures of taps, number one on the left side. Let's take these two switches exchanging a lot of data. And you can see this color ball is actually data packets. I made this presentation myself. I didn't copy it from any source. So I like to make my presentation a bit flashy, full of colors sometimes. It makes it easier for you to understand. Yeah, I know it looks nice, yes. But now there is a purpose for these balls and these colors. So if you see, there is a monitoring tool down there, regardless of whatever monitoring tool we are using. We want to copy this data to the monitoring tool. Now, if you're going to use span is the traditional method. I'm going to use tap. So I'm going to add the tap here. And this architecture is called out-of-band tapping. Now, what it is doing, it is just copying the data to the monitoring tool. Whatever is going, it is not adding any much latency. It's very small latency, microseconds. It's copying everything. So it's not affecting your path. It's not affecting your traffic. It's just copying all that stuff and sending to the monitoring tool. Whereas the second architecture is, we call it inline deployment. Now, this in-band monitoring is mostly useful if you have a sandbox, IPS, IDS, and you want that traffic to go to the sandbox first, analyze there, see what is malicious, what's not malicious, and stop it there, filter there, block it there. And if something which is good, allow it to go to the other side of the network. So any questions here? Okay, looks good. So let's move to the visibility, simple visibility architecture. So now you should be convinced tap is a better way of copying the data or visibility, because tap has no limitation of number of ports or VLAN, it's just copying the data. Now look at the simple architecture here, where on the left side, we have a network, core network, data center, switches, routers. On the right-hand side, we have network operations tools, we have security admin. Well, it gets more complicated. We have even more tools now on the right side. Well, look at that. It increases more. So you have a lot of forensic tools and a lot of application operations tools. So that means all on the right side are all monitoring tools. And these data center switches have to send the copies of the data to these tools for monitoring. So remember, we said taps are the better options. Here we go. We put the taps with the switches. So taps is going to do a good job. That means less load on the switches. Switches can do their regular job, layer 3 switching, routing, and taps is going to take this load off, the mirroring load off of them, and just tap the data and send to the tools on the right-hand side. However, there is something else we have to understand. Even if you use taps, it comes with more challenges. Because when the taps are sending data, well, one data packet can be copied multiple times. So maybe a data is copied from here, and if it's going this path or the other path, he can be copied again. So there's a lot of duplication. So even if you use taps, you might end up with a lot of data being sent to these very expensive tools on the right. So we have even another step of technology called network packet brokers, NPB. The function of NPB is they're more intelligent than taps. And their function is to deduplicate. So whatever the traffic comes from the left, going to the right, it can deduplicate the packets, it can aggregate, it can filter, it can load balance, it can do decryption, it can also send and flow packets. So there are multiple purposes. And then even for network packet brokers, there are different vendors. So again, we are not discussing a specific vendor. It's a very generic discussion. And so in this example, we are regenerating the traffic. That means the taps are doing a good job sending all the data to the network packet broker. Network packet broker is more intelligent. We can configure it to regenerate certain packets of interest. Maybe these red packets are HTTP packets. It has to be sent to all the analyzers or tools on the right side. So we have regeneration function, and deduplication is one of the functions. Then we have filtering function. We can filter certain packets and to send to specific tools on the right-hand side. So instead of showing the slide for all those functions, I prefer to show you what functions are available. So packet deduplication, extended burst protection. So even if you have a micro burst, so the packets would not be lost because the network packet brokers have built-in memory to save that data. So the data won't be lost even if you have a burst. Packet trimming. So some kind of monitoring tools in the network, they are not interested in payload. They just want to see what protocols are being used in my network. So this function in the network packet broker can strip off the payload and just send the header information. Then we have protocol stripping, tunnel termination, timestamping, and this can be, some of these functions can be discussed in the advanced course. I would like to show you more about the network packet brokers. Before I do that, there are also VTAPs, virtual taps, means if you have virtual environment, if you're running hypervisors, it could be KVM, ESXi, Hyper-V. The VTAPs can work with the hypervisor and copy the data, tap the data between the virtual machines and send it to the monitoring tool. So this is another feature available for virtual environment. This example is for a network packet broker. So some of the vendors have taps and network packet broker built in a single device. So you don't have to buy separate taps and network packet broker. So most of them have a built-in function. They can do tap and they can do network packet broker intelligent functions. So in this example, we have two networks, one on the left, one on the right. And we have this, well, the network packet broker can also be called as a bypass switch in this case. And it's connected to an IPS. So IPS, well, intrusion prevention system, intrusion detection system. Nowadays, they call it sandboxes in the industry. So the whole idea is this tap/network packet broker has to send traffic to the IPS to analyze the traffic and to make a decision if the packet is malicious, if the traffic is malicious, to stop it, to filter it. So everything is looking good, and you can see this heartbeat. This heartbeat means this network packet broker sends a heartbeat messages to the IPS, and to see if he's up and awake and breathing. That means he is active. And if the IPS goes down, then the heartbeat would fail. And when the heartbeat fails, the traffic wouldn't be affected. The traffic would still flow through the bypass switch. Well, bypass switch, again, is a tap/network packet broker. So that means even in case of failure of the IPS, the traffic will go ahead. There is another scenario where, what if the whole bypass switch fails? There is a electricity failure, there's a power failure in the switch itself. So they have a built-in mechanism where they can still bypass the traffic through the physical channel. So this is not a point of failure. So this is another good feature of using these bypass switches, which is actually, again, network packet brokers. And bypass switches, network packet brokers, are available in many kind of throughputs: 1 gig, 10 gig, 40 gig. I have seen 100 gig, 400 gig has been introduced. So we have a wide variety of them. If there is any questions, I'm happy to answer them now. And please expect a quiz in the next session. Until then, I wish you all the best and enjoy your next lectures. I created this presentation for you myself, all the colors and all the different kind of traffic. So until then, until next lecture, enjoy yourself, have a nice coffee, and I will see you soon. Thank you and good day. Bye-bye.